Okay, for today, you are doing some good old-fashioned long division. I want to make sure that you remember what we did yesterday too, but if I gave you this polynomial, x to the third plus 27, how do you know it's actually a polynomial? Well, it's all about the power that it's got. It's got a degree of 3, and so therefore it's okay. If the powers aren't strange, it's a polynomial. All right, what if it says this little x minus 3 is a factor and x equals 3 is a root? What does that mean? That means that if I were good enough at this to factor that, I would know that one of the factors is x minus 3. And of course, that means 3 is a 0. All right, what does that really mean? If this is a factor, this is a root, which is also a 0, which means 3 will do what to the equation? It'll make it equal 0. Making it equal 0 isn't crashing it. It'll make it equal 0. All right, so now, is 3 really a 0? Well, put it in there. You put in a 3, is it equal to 0? No, that's not true. That is false. I can tell that they're lying to us. All right. Now, that's a quick way to tell, and that is the polynomial remainder theorem in action. All right. So, you'll learn more about it as we proceed. Moving on. Reviewing yesterday. So, yesterday was about sketching polynomials. Remember how I'd do this kind of a thing? And then these are the important spots. Let's say this is -3, this is 2, and this is 5. You should be able to write me an equation for that. I want to pause for a second while you give that a shot. Write me an equation for that graph. So let's see if you got y equals, and then you should have had an x plus 3 and an x minus 2. Please don't talk right now. And then an x minus 5. And then how come I know there's no negative in front? Did you even think about that? Okay. If you look at the right side and said, yeah, it's up on the right, therefore it must be positive in front, then you pass. If you didn't even look, then you could have got fooled. Because if the right side had happened to have been going down, then this would have needed a negative in the front of it. Okay? All right. So then what if I said I want that whole thing to be greater than or equal to 0? Would you please write the answer in interval notation? Well, I know this is negative here, and I know it's positive here, and I know it's negative in this zone, and I know it's positive in this zone. So that's called the sign chart. What do you say, sir? From -3 to 2. Parentheses or brackets? Bracket. You are correct. Why did you pick bracket?
Because it includes those.
Yes. Another way to say it, it says we're equal to. Okay, and then keep going.
Union 5.
I'm assuming bracket, right?
Yeah. To infinity, no bracket.
There you go. Raise your hand if you had that one right. All right. So, a lot of. That's you guys are a rough crowd. Okay. So this one, sketch it, and now I need to teach you how to write limits. I will teach you the limit part, but you sketch it first. I hope you get that the two key roots are at those green marks, and that's going to be, well, +1 and -2. Did you understand what that's what those marks meant? Okay. And then I hope you notice that it's negative, and so it's going down on the right. Next, if it's at this spot, what the heck? Did you even notice that that's an x plus 0? And therefore it hits also at 0. Did you even notice that? Okay. All right, so at this spot, the +1, It didn't have a power, so we know the power is 1, so it's just a simple cut through. And it has to end by going down, so then I'm just going to simply cut through. And at this spot, it was squared, and so that means it bounces at that spot. And at this spot, it was to the third. Ooh, I got to draw one of those tricky ones. No, that's not a good entry. I got to try that again.
Isn't the X one before?
Oh, it's to the... I'm sorry, I must have drawn perfectly right over the 4. I guess I did. Okay, sorry about that. That means that it is bouncing at the 1. So, crap. Not good, server. I gotta erase this. Hold on a second. I'll be able to see. You are right. Okay, sorry about that. So I will just undo that part. It is bouncing there. So that means boing. And then at 0, is it also bouncing? Yep. Boing. And then last but not least, it's doing one of those snake throughs. These are tough for me. I don't know if they're tough for you, but I would like to do my snake through like that because it's like how x to the third looks. But I got to go the other way. You know what I mean? So let's see if I can pull it off here. There. That wasn't great because it sort of looks like it's a straight line there, but I'll try one more time. There. Okay. How should you check yourself before you wreck yourself? You should make sure, oh, it's negative, so it's down on the right. Next, you should add up all the powers. This was the 4th, the 2nd, and the 3rd. 4, 5, 6, 7, 8, 9. This is to the 9th. Your lead coefficient would be negative 5x to the 9th. That tells me it should be going different directions on each end. And it is. All right. Now we got to grow up from saying up or down. That's how you learn to say the end before. You ready to learn something that you're going to spend it's at least 20% of your time in calculus doing? I get to be the first to tell you about it. It's called limits. All right. Take it to the limit one more time. All right, you ready? So, do you agree that this one, if I continue it, it's telling me that it's just going to keep going down to the right? Okay. There's a way to say down to the right mathematically. Okay? And, of course, there's also a way to say as we go to the left, it's going to go up. There's a way to say that mathematically. All right? So I'm going to start with the one on the right because we read from left to right. And so it makes more sense. We're used to going from left to right with our eyes when we read a book or whatever. We always go from left to right. So that one's a little more logical. So let's look and zoom in at this one on the right-hand side here. See how it's going down as we go to the right? Here's the official way to write it. Please copy this. The limit of the function as the x approaches infinity. Okay, so what I'm saying here is this function is if I continue to the right, that's x approaches infinity. Do you get I could have said to the left by saying if x approached negative infinity? Then I'd be going to the left. But this is saying the limit as I go to the right of this function is, well, what is its limit? Some functions actually do have a highest spot that they go to. This one isn't just going to keep going down like forever. It's not just going to all of a sudden decide to level off and like, oh, the lowest I go is negative 2,000. No, they don't do that. There are functions that do, but you haven't learned about them yet. So they're just going to, this one, we're going to assume it just keeps going down and down and down and down. Does anybody want to tell me what you think the mathematical way to say down and down and down and down is? Negative infinity is the correct answer. That's your first limit statement. The limit of the function as x, remember, approaches. Because we don't want to say it gets to infinity because it won't. As it approaches infinity, meaning as I go way to the right and as I continue to go to the right, my function's y value, this is important, write this down, y value, the y value will be negative infinity. The x value would be positive infinity. You know, it's like if I could scroll way down there, like if infinity was a place, it would be at x is positive infinity, but way, way, way down there, y would be negative infinity. Okay, but we can't get there, so that's why we have to say approaches. And this also is approaches the limit of f of x as x approaches infinity. And we don't say approaches, but can you actually get to negative infinity? No. All right. So then how do you think we say the left side? Don't say it, write it. If you really understood what we just did a second ago, you should be able to write the limit statement for the left end of this function. If you at least had lim of f of x, you've got the right start. What'll always have to be underneath the lim? X approaches. Now, will it always approach the same thing? No. So that's one more thing that'll always be in every limit statement you ever write is that equals. You don't use an arrow. And the way we write this is really important. Some kids get loosey-goosey with this, but I'm telling you, I have to because I've talked to my colleagues about this. Then they really want us to remind you of this. If you decide to like say limit as x approaches, nope, the x is underneath the lim or you're going to lose points on the AP test. You can't just say it any way you feel like saying it. The x arrow has to be underneath the lim. Okay, so we need to learn how to do this right. That's going to be the every limit statement you ever write. Now here are these two red numbers, negative infinity, and in this case, what is the y value when we get infinitely far to the left? Regular infinity, yes. Those red numbers, those will change problem to problem. But you'll always, oh, and I see one from the back row here, and I'm just going to copy what this person wrote. Is he looking at me? And they just lost points in the AP test. Why? The x goes to negative infinity. It's all supposed to be underneath the lim. Now, is mine perfect? No, but this is straying far enough that I would have had to call it out on the test. That needs to be further to the left. So whoever you are, you know who you are. Keep it underneath the lim. If it happens to just barely go underneath the f, I could live with that. You spread it all the way underneath the f of x? No. It's supposed to stay underneath the lim. Unfortunately, my phone thinks it's a normal Thursday, and so this is not our 12-minute warning. You thought it was over already? Oh, no. No. We still have several hours left. Just kidding. Okay, so I'm going to give you another one, and I'll give you the picture. I'd like you to write the limit for the right side, and then on the left side, write the limit for that. Go ahead, give it a try. Okay, so you should have said on the right-hand side that the limit of the function as x approaches, I get it wrong. Why?
Oh, it has to be all on the limb.
It has to be underneath the limb. X goes to infinity is infinity. Raise your hand if you had that one right. Awesome. Then on the left side, you'd say limit of the function as x goes to negative infinity, would be the left side, is negative infinity. Raise your hand if you had that one right. Okay, awesome. I think you're getting the idea. That's how you write a limit statement. Okay, so from now on, when we ask you to describe the end value of functions, you are going to use limits. Limits will get much more complicated, but there's your introduction to limits. Okay, it's kind of like projecting into the future. All right, what's going to happen someday? It's a Nostradamus of math. All right. So long division of whole numbers. I got to get you through long division. Do you remember it? I hope so. 3 goes into 37. It goes in there. Follow me to every step. Ready? Because if you can't do this, when we do polynomial long division, you will be totally lost. So now some of you are like, but I never got this when I was 7. You're going to get it now because you're smarter than you were back then. No, I think you're smarter than you were back then. You barely were tying your shoes and you were doing this. All right. Okay, that's a different thing. You can get Velcro for that, but we need you to be able to do this. So I go, why'd I put a 1 there? Because 3 goes into 3 once, and then when I go this times this, I get this. Why does this matter? Because we're going to have variables, and you're going to go this times this, and you're going to put it there. All right. Then, what's the next thing I do?
You put the 7 down.
No, you do not. What do you do first? You subtract it. Notice I'm making this the opposite of what it was. Then I got a 0, and then I bring this 7 down. So many steps. All right. Now, 3 goes into 7. Yeah, twice. And then 3 times 2 is 6. And then notice, change the sign of the 6. I know you're thinking, but that's just minus. You're going to have to change the signs when it's polynomials. They might be minus, plus, minus. And when you change the signs, it'll change to plus, minus, plus. Do you get what I'm saying? So it's going to be more complicated, but there's this change the sign thing. Then this is a 1. And then you need to know, what does that mean? The answer is 12 and 1. What? Yeah, but that's back when you were in elementary school. You're supposed to be smarter than that. 12 and 1/3.
Where'd you get the third from?
Didn't know that?
1 divided by 3.
It's this divided by this. Okay, so maybe that's an aha moment for some of you. So let's do one more like that. 8 goes into 450.
Whoa.
Does 8 go into 4? No, so you put a 0. And you can just not do anything else except move on and say, does 8 go into 45? How many times? 5 times 8 is 40. Notice me changing it to the opposite. And then I subtract and I get 5. And then I bring down the 0. Does 8 go into 50? Yeah, how many times?
6.
6. 8 times 6 is 48. And there's a 2 left. But you don't just say remainder 2.
1/4.
56.
Say 2/8, which you could just instantly reduce to 1/4. So the answer is 56 and 1/4. But wait, there's another way you could have done it. Let me show you something. Let me show you. Ready? You could have said it was 8 times 56, but then add the remainder. That would also equal 450. You didn't know that. Now you know it. This times this, then add the remainder, and you will get 450. Learning stuff? Okay. So, why do you care? Because in a moment, you're going to be doing polynomial long division, and this will matter. Like, you're going to have to be able to do it to get a good score on your next test. Okay, so let's make sure you get this. Do you remember doing it? Doing polynomial long in honors higher algebra?
Yes.
All right.
There's an easy way.
Yes, and I know some of you are like, yeah, but I just always did synthetic. No, you won't be able to do synthetic because the kind we do are too complicated for synthetic. You'll have to be able to do polynomial long. All right, so watch. This one. If I had said 48 divided by 6. Let me just side note. 48 divided by 6. How would I write that with the little house thing? What would go under the house?
48.
48. And notice you put that number divided by the 6 like that, right? Okay, so which number goes where if I'm doing, is that a factor of that? Notice this was the factor of that.
X plus 3.
So basically, the bigger number goes under the house. I'm oversimplifying here, I know, but we need to get moving because it's a shortened class hour today, so let's do this thing. That goes underneath the house. Square root of x to the third plus 2x squared minus 23x minus 60. And then what goes outside the house? Would you agree that's a little bit like a bear den? He climbed into the den. You know, bears den up in the winter. They don't just wander around like, gee, there's nothing to eat. It's so cold. They hibernate. They climb into a den, right? The dividend is in the den. Dividend is in the den. Do you guys know what the other one's called? The divisor. No. The divisor is the divider. All right. Dividends in the den. Okay, anyway. You guys are a little crazy, but I guess it's like a Friday for you, isn't it? Okay. Let's put an X here. That's how I would always start if I were you. Now, it turns out this isn't actually exactly right, but it's a great way to start and then think it through. You're going to go this times this, and you're going to put it here, just like we did before. But x times x would only give me x squared. Would that work nicely? No. So you shouldn't just use an x. What should you use? Exactly. Okay, so if that's x squared, then I'm going to go that times that. And that'll make x to the third. And then I'm going to go this times this. You have to distribute. X squared times the 3 makes 3x squared. Now notice I need that plus in there. And then I draw my line, and then wait. Those are all the same. Nothing would cancel. Do you remember that on our long divisions, we always change the sign right here? And then a classic mistake is to forget to change that one. You have to change both of them. I made it blue so it would stand out. Do you see it?
Yes.
That's really important. Change the signs on both of them. Okay, now, when I put these together, don't think of it as adding or subtracting. It's combining them. If I combine those two, what do I get? When I combine those two, what do I get? So you write negative x squared. Okay. So next up, I'm bringing this down. Do you remember that part? How many of you already did that because you just kind of knew that was going to happen? Awesome. Now, I got to think about what to put up here. Negative x. You are correct. Now, when I take that negative x and multiply it by this, the reason I know it worked is because I got the exact same thing so that it will cancel. Do you get what I'm saying? The front term has to cancel each time, or you didn't put the right thing there. Like these guys that I'm shading in blue here, they have to cancel each other, or you're doing it wrong. The next ones, these two, they do not have to cancel. But the lead one, they have to cancel each time, or you picked the wrong thing. All right. So now I'm going to continue my multiplying. This times the 3. And I get negative 3x, and I draw the line. Classic mistake time. Opposite, opposite. Now, these didn't matter that much because they just canceled. But then kids forget to change that one, and all heck breaks loose. Okay, so next I have negative 20x. And can I just be done? No, you must finish the job. Minus 60 goes here. And then what do you think I should put up top? Minus 20, very good. Negative 20 times the x will make negative 20x. And the negative 20 times the 3 makes negative 60. Change signs, combine them. I have no remainder. I can factor. That's what you really just did. You just factored. X plus 3 apparently is a factor because why? Because there's no remainder. If there had been a remainder, we wouldn't have said it was a factor. All right, so you're not really done until, and I remember my dad telling me this about fishing. We'd go fishing, catch a bunch of fish, bring them back to the house, and he'd say, you're not really done until you got them cleaned up so we can eat them. All right, I apologize to the non-fish eaters out there, but my family ate fish. So we would actually eat those walleyes, and they were amazing. You need to finish the job by writing out the answer like this. You can't just quit and go home because you're tired. These are long, difficult problems. And then wait, I still get it marked wrong because I didn't finish. You know why? That part can be factored. Don't. I quit.
It happens every time.
You're too late. You're stuck here now. Okay. So there. It's factored all the way. And you get how at the end it was super simple factoring? At the beginning, if I'd have just said, hey, factor this, you guys, most of you couldn't. Some of you actually could. I know, I should never challenge you because somebody probably would have figured it out. But
AKA me.
But
Yeah, I would have been Sam.
Look at the video.
there is our final answer.
Do we have to find the zeros at the...
All right. It depends on the question. On the test, we would sometimes just say factor it, and on sometimes, if it was an easier factoring one, we might say, and tell the roots, which, like you said, different thing, -3, 5, and -4. That means those are the three things that are roots, but they're also called zeros, which would mean if you plug those numbers in here, it will make the equation equal 0. Don't forget that roots also mean zeros, which means it'll make the equation equal 0. And stop saying crash it. 0 is not crashing a function. Having a 0 in the denominator is crashing a function. Okay, everybody try this one without any help. I'm going to pause. Give it a shot. A little more Edmonds Fitzgerald. Okay, so I'm hoping you put the dividend in the den. Now, this one was on purpose, not in order. Did anybody catch that? Yes. All right, good. So I'm going to switch those around. Yep. And it's a minus, though. So this needs to be minus 4x squared plus 8x minus 16. Now, what if they had just completely left out a term? Like there was no x squareds at all. Then I would put a 0x squared there to hold the place. You can still do it without that, but pro tip, if they don't have one of the powers, like you got 3, 2, but you don't have any 1s, put a 0x to the 1, or in this case, x to the 2. All right, so we did have all the powers represented. They were just in the wrong order, x minus 2. And I can tell right off the bat, because I've done this a few times, this has got to be a 2x squared. So that when I times it by the x, it'll be 2x to the third. And then that's minus 4x squared. Oh, sweet. Two of them are going to cancel. Opposite, opposite. And they're opposites of each other. So I got nothing left. I can be done. No, I can't. Drop these two down. And then technically, you know what happened is nothing went into those two. Technically, you'd have to say 0x. But do you think I really have to write a 0x up there? No, I don't have to. But that's kind of what's happening. All right, so now I'm going to say plus 8x minus 16. And then I got to match that up. So what do I put here? Plus 8. 8 times x is 8x. Awesome. 8 times the -2 is -16. Draw a line. Opposite, opposite. Cancel. 0 remainder. It worked. That's factored. So I do my job and finish it all up and like not just, yeah, clean the fish. Very good. And then I have 2x squared plus 8. And then I get it wrong. Why? Not factored all the way. Do you get how there's a 2 in both of them? Could I have factored a 2 out of everything at the very beginning? Yes. Look at that. And it would have made all my numbers easier the whole time. But you didn't have to, as I proved right there. You could factor them out at the end. But just whatever you do, look at your answer and see, is there any way I can factor it further? All right. Yay. You know math. Now, we'll get to the homework. Everybody find this page here. And it's asking you to do some long divisions. I would like you to, let me just look a little further. I know we're going to do some of those, but enjoy an easy one. So just that yellow first page. All right, you now know how to survive if you fall through the ice. Have a great day.
How much did that?
I want to see how many I have of what kinds. All right. We're just going to do the first page.